Hi, Chem 101 students. Welcome to the second lecture about atoms and the periodic table. In this lecture, we're going to talk about subatomic particles, the structure of the atoms, the way they're arranged, what the meaning of a word called isotopes, which will be a very important word for us, and the different types of elements that you will encounter. This is going to follow section 3.1 of the textbook. So that's the section you should be reading along with this video, whether you read it before or after, and make sure to try the example problems in there as well. So let's get started talking about the content in lecture 3.2 here. So we've talked about these little tiny things called atoms. They're the little pieces of stuff. But what are these things? What makes one type of atom different from another? And so we're going to talk now about the pieces that make up atoms. These pieces are called protons, neutrons, and electrons. Oops. So the first of these that I'll talk about is the proton. We're going to say that it has a charge of +1. Now, what is a charge? Okay, a charge is if you think of a charge like it's an electrical charge, it's kind of like a magnet. So you know how sometimes magnets, if you face the two sides close to one another, they'll stick. But if you turn it around and you try to press them together, they won't stick. You can think of them like that. There's going to be basically two sides to charge. One side will be called positive, the other side will be called negative, kind of the way there are two sides to magnets. So a proton is said to have a charge of +1, and it has a mass of 1 atomic mass unit, also called AMUs. So these AMUs are actually really, really small. It's 1.673 times 10 to the minus 24 grams. So we're talking super tiny. Super tiny masses. It's because atoms are really, really, really small, and so they don't weigh a whole lot, and their pieces, especially that make them up, don't weigh a whole lot. Another type of particle or piece that makes up atoms are called neutrons. So these neutrons are called neutrons because they're neutral, meaning they have no charge, neither positive nor negative. So they have no electrical charge. But they also have a mass of 1 AMU, 1 atomic mass unit. Their mass is actually slightly bigger than that of a proton, but we round them off and say they're both approximately 1 atomic mass unit. Finally, there's a third type of subatomic particle, or pieces that make up all the atoms that make up everything in the world. These are electrons, and these are said to have a charge of -1. And what this means is that because electrons have a charge of -1 and protons have a charge of +1, we will say that they are attracted to one another. So there is a force of attraction between them, and they will accelerate towards one another if they're close, kind of like if you drop a ball from above the earth and you drop it, it will fall towards the earth because they're attracted to one another, the ball and the earth. That attraction is due to gravity. This attraction is due to electrical charge. And the electron, what makes it different from the proton and the neutron is that it has a very tiny mass relative to them. Even though they have tiny masses themselves, the mass of an electron is about 1/2000th of the mass of a proton. And so the mass is much less than that of protons and neutrons. And so its mass is only 9.019 times 10 to the minus 28 grams, super tiny. And so the construction of the atom will be like this. The electrons are really tiny, they don't weigh a lot, they weigh so little. They kind of go around the outside of the nucleus. So these right here are the electrons that you see kind of moving around the outside of the atom. In the middle of the atom, there's a region that we're going to be calling the nucleus. And this is where the protons and the neutrons are going to be. right in the middle there. And so let's talk about what that means and what that means for various elements. So here's a diagram of that, a little simpler than that artist drawing that we had there. So in the middle, in the nucleus, the protons and the neutrons reside in the middle. And the electrons go around in regions called orbitals. So in that last diagram, it kind of showed them orbiting like in a circle around the middle. That's not really the way electrons move. Electrons move in a very strange way where we can't really say a whole lot about where they are and where they're going. And you may think that's very weird, and it is. That's the realm of quantum mechanics, and very weird things like that happen when we look at things on a very, very small scale, smaller than an atom. But the main idea here is that the nucleus contains the protons and the neutrons, and these are in the center of the atom. The nucleus is very small, so this picture greatly exaggerates the size of a nucleus because I need to be able to fit proton and neutron in there. So does the last picture. The nucleus is actually extremely small compared to all of the atom. An example or analogy would be like if the whole atom was a stadium, the nucleus would be a baseball in the middle of the stadium, of the entire stadium. So the nucleus is very, very small in terms of the size of the volume of the atom, but it has all of the positive charge because all the protons are in there and they're the positively charged parts. The orbitals are regions where the electrons move around. We say that it's regions where we are probable to find electrons. So I'm going to say a little bit more about this as we go into more detail next week, talking about the movement of electrons around an atom. But these we can't really say exactly where the electrons are at any one particular point in time. I know, very strange. We'll say a little bit more about it next week, but we won't go into that much detail in this class. The idea is that these electrons move around outside of the nucleus in some fashion. They're really buzzing around all around the outside here in regions that we call orbitals. So this here is a typical hydrogen atom, and what makes hydrogen hydrogen is that it has one proton. Now, you should have your periodic table from the very first module where I put the reference information. There were two things: a periodic table and a list of elements here. So the periodic table, if you look at it, you'll see hydrogen is up here at the top left, and it has a number in it, 1. You may have wondered, what does that number mean? It also has another number. We'll talk about that in the next lecture, this number. But right now we're going to focus on this number. The 1 here is the number of protons. So hydrogen atoms have 1 proton. Helium atoms have 2 protons. That's what makes them helium atoms. All lithium atoms have 3 protons, and so on. The number above each of these atoms here is the number of protons. So and we call this the atomic number. So the atomic number of hydrogen is 1, and the atomic number is equal to the number of protons here. An atom is charge neutral, meaning it does not have more positive or negative charge. What this means is that in any neutral atom, the number of protons, which are the positive charge, so the protons here are the positive charge, must be equal to the number of electrons, which are the negative charge. We will talk about particles that are not charge neutral. Those are going to be called ions, but we're not there yet. We're going to talk about charge neutral atoms. They have no charge, and this is because the number of protons is equal to the number of electrons. What about the number of neutrons? Well, you can have an atom that has the same number of protons, but it has different numbers of neutrons. And this is very, very common. When we pick up, a handful of water with a bunch of hydrogens in it, most of them have one proton and no neutrons, but a few of them have one neutron. And we say that when two atoms have the same number of protons, but they have different mass numbers or different numbers of neutrons, we say that they are isotopes of one another. So this is hydrogen. It has one proton in the nucleus, one electron. And this one is called hydrogen 1. The 1 here is the mass number. The mass number is the number of protons plus the number of neutrons. So since this has one proton, that is already mass 1. So it must be 0 neutrons in hydrogen 1. Otherwise, if it had one proton and one neutron, its mass number would be 2 instead. So this is called hydrogen 1. It's indicated either as an H with a 1 up as an exponent on the top left side. The area where it is really important. That area to the top left of the symbol tells you that this is hydrogen 1. Or you can also write it like this, as hydrogen-1. It means a hydrogen with one proton and 0 neutrons. The mass number is 1, 1 plus 0. This is by far the most common type of hydrogen atoms. Over 99.9% of them are hydrogen 1. But a few of them are hydrogen 2. So what is hydrogen 2? Hydrogen 2 is a hydrogen atom with a mass number 2. It still has one proton, because if it had a different number of protons, it would no longer be hydrogen. But it has one proton and one neutron, so the mass number is 2, because the mass number is the number of protons plus neutrons. So we've got here one proton plus one neutron, so 1 plus 1. This is 2. The mass number here is 2. So there must be one neutron in this hydrogen, because if there wasn't, the mass number wouldn't be 2, right? It's 1 proton plus 1 neutron. But because it's hydrogen, it must have one proton. Because the mass number is 2, it must also have one neutron. So that total mass is 2 atomic mass units. Finally, an extremely rare isotope of hydrogen, but one that does exist, there is some, is hydrogen 3. So hydrogen 3, indicated with a 3 at the top left, or hydrogen-3, this is a very small percentage of hydrogens have this mass number. It's mass number 3. This is because the mass number, again, is number of protons plus neutrons. So here we have this time 1 proton plus 2 neutrons. And so we have a mass number here of 3. It must be 2 neutrons to make a mass number of 3. 1 proton plus 2 neutrons. And so these are 3 isotopes of hydrogen. Notice they all have the same number of protons, 1, because they're all hydrogen. What differs is the number of neutrons. And other elements have isotopes as well. We're going to talk about those. So let's say, a very common question I'm going to ask you in this class is, how many subatomic particles are there in this atom? How many protons, how many electrons, and how many neutrons? To find the number of protons, it's easy. You just find the element on the periodic table and find its atomic number. The number of protons is the same as the atomic number. Second, if we have a neutral atom that isn't an ion, we'll talk about ions later. Right now we're only talking about atoms. Since atoms are neutral in charge, there must be the same number of negative electrons. Remember, electrons are negative, as there are positive protons. The hardest one to figure out is the number of neutrons. Because remember, the mass number that we had, mass number, is the number of protons plus the number of neutrons. So if we just want the number of neutrons, we're going to have to isolate that. We can do this with algebra, or you can just memorize this, but it's probably better to understand where it comes from. If you understand that mass number is the number of protons plus the number of neutrons, and we subtract the number of protons from both sides, then this cancels here. Protons minus protons cancel. And we get finally that the number of neutrons equals the mass number minus the number of protons. So the number of neutrons will be your mass number. And remember, your mass number indicates your protons and your neutrons minus the number of protons. So you're subtracting out the protons. And when you subtract out the protons, then all you've got left, so protons here, subtract out the protons, then all you've got left is the neutrons. So that's why to get the number of neutrons, we take the mass number and we subtract the number of protons. Now, let's look at an example. How many protons, electrons, and neutrons are there in sodium 23? So remember, 23 is the mass number. What we need is the atomic number. So what we do is we pull out our periodic table and we look for sodium, Na. That's right here. And its mass number is, so it's on the left side here, the mass number is 11, right there. So we know that sodium has 11 protons. Sodium has, we look up the atomic number for sodium, and there are 11 protons. Since this is a neutral atom, the number of electrons must equal the number of protons. So there are 11 electrons. Finally, we have to figure out the number of neutrons. And remember, the neutrons are going to be the mass number minus the number of protons. So our mass number here is 23. 23 right there, mass number. And we're going to subtract the number of protons, 11, so we get 12. There are 12 neutrons in sodium 23. So remember, every sodium atom must have 11 protons, otherwise it's not sodium. What can differ? The number of neutrons. In this case, this sodium 23 has 12 neutrons. How many protons, neutrons, and electrons are there in nitrogen 14? So again, we look at the periodic table here. Nitrogen 14, well, we look first for the atomic number. The atomic number for nitrogen is 7. Right up here at the top. So the number of protons is 7. Cha-ching. I'm going to show you why I'm cha-chinging in a second. The number of electrons must be equal to the number of protons. Cha-ching. It's 7 electrons as well. Now what about the number of neutrons? Well, again, the number of neutrons is going to be the mass number minus the number of protons. This is going to be, the mass number is 14. 14 minus 7. So this is going to be 7. 7 neutrons. 7, 7, 7. Ding, ding, winner. All right, like a slot machine. This is the luckiest isotope, I think. Triple sevens. Okay. So now I want you to decide how many protons, neutrons, and electrons are there in nitrogen 15. So you should probably pause the video for a few seconds and try to figure this out. And then right after you pause it now, turn it on, and I'll show you the answer. Okay. So let's look now for the answer. Well, it's nitrogen again, so it must have 7 protons. If it didn't have 7 protons, it wouldn't be nitrogen. So this, we look up the atomic number, there are 7 protons in nitrogen. Next, the number of electrons has to be equal to the number of protons. So there are 7 electrons here as well. Then the number of neutrons is going to be the mass number minus the number of protons. Mass number is 15. The number of protons is 7. So there are 8 neutrons in nitrogen 15. Notice the difference in these two isotopes is the number of neutrons. Nitrogen 14 had 7. Nitrogen 15 has 8. They differ in neutrons. They do not differ in protons. They both have 7 protons. Okay. And that's how you figure out how many protons, neutrons, and electrons for your homework this week. So now you've noticed we've been looking at the periodic table a lot. From now on, you probably should have your periodic table with you. It's going to be really, really useful. You'll want it for the next lecture as well. On top of that, you're probably going to want your list of elements and ions. You're going to start memorizing these now. Not the ions yet, but the elements. We haven't gotten to ions. So to follow the lectures and to complete the exams and quizzes in time, you're going to have to be familiar with these symbols that we've started to use now in this week. And so this week, you'll notice the lecture is a little lighter than last week. This is because you've got some memorizing to do. You've got to memorize the association between the names and the symbols for each of these elements. You might think, well, I could have any periodic table I want because we're online, right? And that's true, but you will be too slow following me, I feel like, if you don't have these memorized. So since we're online, it's possible you could get away with not memorizing the names and the symbols, but I would not suggest trying that. It's a bad idea. So these are listed on your list of elements and ions. Were located in the first module. I recommend you print these out and you keep them beside you while you're working. Also listed here, so not all the elements are included, okay? It's only a selection of them. You don't have to memorize all of them. They're also listed by their type here, like alkali metal, alkali earth metal. You will also have to be able to identify their type. But again, this won't be hard as long as you have a periodic table. Their type is indicated by their position on the periodic table. And so you'll see that these in the first column here, which I'll be calling group 1 later, these are all called alkali metals. And you'll see they're called that here on this. These are all the group 1s. They're called alkali metals. In this second group here, these are all called alkaline earth metals. Here. And you can see they're listed right here, alkali earth metals. Next we have the transition metals. All these yellow ones are called transition metals. These ones down here are called basic metals or other metals. And then right here in these turquoise ones, we have the interface between metals and nonmetals. These are known as semi-metals. They kind of are like metals, kind of are like non-metals. And then we have up here, we have nonmetals, and all these above the semi-metals are nonmetals. A particular type of nonmetal here in this column, these are called halogens, or these light purple ones. These darker purple ones are called noble gases. And then down here, these are called the inner transition metals, or they're also called the lanthanides and the actinides. There will be a question on the quiz and on the exam for you to look at the periodic table. You will have a periodic table and identify what type of element each of these are, or what type of atom. So make your flashcards this week, memorize these elements and symbols. You're going to need to know that N is nitrogen. Some of them are hard, like Na is sodium. Why is Na sodium? Well, this is because some of these elements were known in antiquity, maybe 1,000 or more years ago. And so they were named in Latin originally, and the name kind of stuck. So the Latin name for sodium is natrium. That's why it's Na. Or the Latin name for iron is ferrum. That's why you see Fe here. Or for copper, it's cuprum. Or for silver, it's argentum. Gold, it's aurum. So that's why some of these have symbols that are kind of seem to not have a relationship to the name, and it's just because the symbol comes from the Latin name. But for a lot of other elements like chromium, Cr, cobalt, nitrogen, oxygen, carbon, these symbols make a lot of sense because they're based off of the English name. So now you're looking at the periodic table, you also see this kind of funny shape to it here. There's a reason for this shape, and there's a reason why the elements in a certain column have the same name to them. And this is because the elements that are in the same columns, which we also call groups in chemistry, they have similar chemical properties to one another. And so they are arranged in this column, in this group, because they behave in a similar way, and they react with other elements in a similar way. And when we get into the next chapter next week, we'll actually have explanations for why this is true. Horizontally, the rows that go horizontally, these are referred to as periods. And atoms across a period have approximately the same size to them. Atoms do get bigger and bigger as they have more protons and neutrons in them, and for other reasons, which we'll talk about next week. But atoms that are in the same period or row have approximately the same size to them. So let's do a little bit of practice. Give the type of element here. Potassium. What type of element is that? This is in group 1. It's K right here. Potassium is an alkali metal. Alkali metal. Okay. So what type of element is cobalt? Cobalt is right here in the middle. It's in the yellow part. These are called transition metals. And then what type of element here is fluorine? Note the spelling, okay? Spelling's important for these. Fluorine is with a U, fluorine. Okay. It's right here in this light purple column. These ones are referred to as halogens. Halogen. Okay. And so that's the end of the lecture here about the subatomic particles and the different types of elements. Just remember, an element is different from another element, or an atom is different from another atom because it has a different number of protons to it. All carbon atoms have 6 protons. All hydrogen atoms have 1 proton. All lithium atoms have 3 protons. Okay. And they're arranged on the periodic table in this fashion in groups. The groups have similar chemical properties. What we'll talk about in the next lecture is the other number that you see in the box here. It's pretty hard to see on this periodic table, but excuse me, and see it really well on these ones. What is this number down here? In the next lecture, we're going to be talking about what that number is. And so I'll see you in that lecture.